Here's another example of where the sample means of the three different populations are the same in both of these pictures, but the variances are a lot bigger on the left than they are on the right. On the left, the data looks a lot more similar to one another. On the right, they look less similar, even though the actual means of the different populations are the same in these two pictures. Okay? So at the end of the day, we're comparing the variances of these individual populations to the pooled variance. If the individual populations have a much smaller variance than the pooled thing, then we have good evidence that the means are different and the populations are different. If they're not very small compared to the pooled variance, then we don't have good evidence that the populations are different. Okay? And so this leads what's called to the F statistic. This is our sample statistic, or our test statistic for this chapter. It's called the F statistic. And yeah, basically it's some way of measuring the variation among sample means divided by the variations of all the data that we have. And so, how do we actually do that? Well, here's the formula for what it is. So F is equal to MSG over MSE. This numerator, the mean squared for groups, this is some way of measuring the variance of all the different subgroups individually, whereas in the denominator, we have MSE, which is the pooled variance of all the data put together. Okay, so we're dividing the individual variances by the pooled variance. And well, as always, this thing will have some distribution that we know, assuming null hypothesis is true. And so that means we can have a table of different values that we can use to find p-values and so on. I think we'll talk about that more next time. So yeah, so that's it. I do have the midterms that I brought last